This is the Math 227 Statistics. Today's topic is Chapter 6, Homework, Examples. Examples of Chapter 6, Homework. First question, example. If the majority of data values fall to your homework is the left, I change to the right of the mean. Majority of data fall to which is the right of the mean. Here it's mean. To the right of the mean is fat. To the left of the mean is skinner. Slim. Then the distribution we call skewed to the left, or call left skewed, or call negatively skewed, because on real number line, to the left of 0 is a negative number. To the right of 0 is a positive number. From negative to positive. So left is negative. So this answer should be A. Now, if the other side, the other way is if the left is a majority of the data fall to the left of the mean. This side is a fat. Left side is a fat. And the right side is a slim. Then this we call skew to the right, or right skewed. And that is also called positively skewed. And symmetric is this kind. Bell-shaped evenly. That's a symmetric. Question 2. For a normal distribution curve, which is this bell-shaped symmetric, and the mean is in the middle, and the left side and the right side is going to be approach to x-axis but never touch it, and like this normal, the mean is 9, so mean equal 9, mu equal 9, and the standard deviation is 3, so sigma equals 3. And which of the following ranges of the variable will define an area under this curve corresponding to a probability of approximately 95%? I changed the number. Your homework is 34%. So I changed to 95%. So this, we are going to use the empirical rule. Empirical rule, also called 68, 95, 99.7 rule. So is within standard deviation about the mean. Like a mean is 9. One standard deviation is 3. 9 add 3, so this is 12. 12 is one standard deviation above the mean. 9 minus 3 is 6. 6 is one standard deviation below the mean. And within one standard deviation above the mean, this area under the curve is 68%. And since it is a symmetry, so you divide it by 2. So each part is 34%. This is 34%. Add together, total 68%. That's one standard deviation above the mean, according to the empirical rule. 2 standard deviation. Mean is 9. 2 standard deviation. So you add 3 is 1 standard deviation is 12. Add another 3 is 15. 15 is 2 standard deviation. 3 times 2 is 6. 9 add 6, 15 is 2 standard deviation above the mean. And the minus 3, total minus 6, guess 3. So 3 is 2 standard deviation below the mean. The probability under the curve, 2 standard deviation above the mean. From 3 to 15, the probability is 95%. 95%. 3 standard deviation above the mean, it's going to 3 minus 3 is 0. It keep going on to 3 standard deviation. 3 minus 3. 1 standard deviation is 3. So 3 minus 3 got 0. And 15 add 3, it's 18 here. 18 is extremely very close to x. So under the curve, from 0 to 18, the probability under the curve is 99.7%. 3 standard deviation above the mean is 99.7%. So this is an empirical rule. Now this question asks you, which one is approximately 95%? Is it 7.5 to 10.5? 7.5 is here. 10.5 is here. Is that between it? No, because it's not possible. 95%. Is 6 to 9? 6 to 9 is 34% under the curve. 6 to 12? 6 to 12 is 68%. 1 standard deviation above the mean. 3 to 15. 3 to 15 is 2 standard deviation above the mean. It's 95%. That's correct. So answer is D. The next question. Question 3. If the average weight, the average means mean of adult male bison, it's in a particular federal wildlife preserve. I changed the number, 1,330. That's mean. Mean equal 1,330. So this is the mean. And the standard deviation is 240. This is 240 standard deviation. And find the weight of an adult bull whose z-score is positive 2. I changed the number. So z-score is 2. So use z equal x minus mean over standard deviation. Then you do z times standard deviation equal x minus mean. So x minus mu equals z times standard deviation. Then add mean both sides. So x equal mean plus z times standard deviation. So plug into this formula. X equal mean is 1,330, plug in, plus z use 2, plug in, times standard deviation is 240, and add together 2 times 240, 480, add together is 1,810 pounds. Then question 4. Question 4, it's find two z values. One is a negative, one is a positive. One positive, one negative. That are equal distance from the mean. The two z values equal distance from the mean means 0. So that the area in the two tails is 5%. This is the same as your notes question, 5%. Your homework is 10%. I changed to 5%. So 5% you divided by 2. So this tail is 2.5%. Transfer to move decimal to left 2 position. Got 0.025 in decimal. This side also add together total 2 tail, total 5%. So then we have to look at the table. This is 0.25. Then z-score is what? So we look at negative z-score equal negative table, this table, and we're looking for 0.025. So you look at this body, this table, this is use this. This area in here in the body is the area to the left of z-score. Now this, what we want, this area is 0.025. So you look at the body, 0.025. Like this, 0.025 here. 0.025 is this area. It's corresponding z-score, this area. Corresponding z-score is go to the left, negative 1.9. Go up, this. So it's a negative 1.96. So we got this z should be negative 1.96. And the other side, since for the normal distribution, this bell shape is symmetric. So the other side is positive. Positive z equal 1.96. So solution, answer, z-score is positive negative 1.96. Let's try another example. If 2 tails total is 20%, that divided by 2, left tail is 10%, right tail also 10%. 10% you go to decimal point, is move decimal point to the left 2 positions, get 0.10, which is 0.10, which is 0.1. It's the same, equal. Then you are looking for 0.1. This probability is 0.1, the corresponding z-score. The corresponding z-score. Now, 0.1. You look at the table here, 0.1 here, 0.120, 0.1 is here. And here, between the two, it's 0.1. 0.1003 and 0.0985 between the two numbers. And this one is much closer to 0.1000. This is a far away compared with this. This one is much closer to. So to the left is a negative 1.2. To the top is 0.08. Put together, it's negative 1.28. To the left, this to the left, negative 1.2, and to the top, 0.8. So it's a negative 1.28. Now, in order to get more accurate answer, we can look at another one. Which one? Do I have it? I think I have. Which is yeah, here 20%, which is here. In the future, you will learn this. You will learn this. 80%. 80% is this is 20%. 2 tail total 20%. On 2 tail 20%. Between it's 80%. You will learn this T distribution table. 80%. 80%. And then because in this table 80% is between it's 80%, and 2 tail 20%. So this is 2 tail 20%. So you look at 80% between 80%. Go down to the bottom, have the z-score 1.282. 1.282. You can see the value. This value has been rounded to 1.28 in the textbook. They rounded, but you want more accurate, because 1.28 the probability is 10.03. 10.03. We want 10%. This is 10.03%. So, and since we won't be able to get just, it's between 0.1000 is between the two numbers. So the value should be between negative 1.28 and between negative 1.29. So it's over here. If you want more accurate, you can use this one, more accurate. It's between it's 80%. The 2 tail is 20%. And go to the bottom. This is 1.282. That's a more accurate answer. The next question is find two z-values, the two z-values, so that 98% of the middle area is bounded by them. So it's between them. This area is 98%. I changed the number. So 100% minus 80% is 2%. 2% divided by 2. Each tail is 1%. So this area should be 0.01. 1% is 0.01. And the 0.01, you look at the table. This is a table area. 0.01, it's about here. 0.01 is here between 0.01 0.0102 and this, between the two. So the answer should be between negative 2.32 and the negative 2.33. And which one is closer to, and this one is closer to the 0.0100. This one is closer because, and you can answer this one, negative 2.33. But if you want more accurate, if you want more accurate, you can look at this table, this one. Between is 98%. So you look at 98%. 98%. This is a T table. You can find this T table in the formula sheet and the table PDF file. 98% go down to the bottom. This number, 2.326. This bottom one is for Z-score. The others for T-score. You will learn T-score later in chapter 7. So this is Z-score. Here say Z-score. Is 2.326. That's more accurate one. So this should be 2.326. This is a negative 2.326. More accurate one. If you round it, in textbook is rounded, it's a negative 2.33. If you use this table, you will figure out it's a negative 2 point, this one. It's between the two number. Between the two number. And we looking for, it's 0.0100. 10%. This is a 10%. If you subtract 0.0099 and the difference is 0.0001. If you subtract 0.0102, this one, you minus 0.0100, the difference is 0.002, negative. Positive. So this one is closer than this one, smaller. Difference is smaller. So this one is closer. So you choose negative 2.33. It's the same answer as this number. You round it is negative 2.33. And the more accurate one is this T table. You will use this T table in chapter 6. Here 98% is in between. Here is 98%. And go down to the bottom. That bottom number is for Z-score. Z-score. And then you got 2.326. That's more accurate one. 2.326. Rounded is just 2.33. Here one two Z score. So one positive, one negative. Next example. Given that the average, which is mean, early bird special admission price for a movie is $5.50. So given mean is $5.50. If the distribution of the movie admission charges is approximately normal distribution with a standard deviation, so sigma, $0.50. And what is the probability that a randomly selected admission charge is more than 4.50? So we're looking for X is more than $4.50. So we're looking for X greater than $4.50. So first of all, we have to find out, we're looking for probability of X greater than 4.5 is same as 4.50. We have to transfer 4.5 to Z-score, corresponding Z-score. So plug into the Z formula, Z equal X minus mean over standard deviation. X use 4.5 plug in, minus mean is 5.50, standard deviation is 0.50, subtraction -1, over 0.50, 0.5 is negative 2. So when x is 4.5, corresponding z-score is negative 2. So when you're looking for probability of x more than 4.5, it's the same as probability of z-score greater than negative 2. And and we won't be able to use the table because to find out greater than negative 2, because the table is to the left, is not to the right. Greater than negative 2 is to the right of negative 2. So we have to transfer when z equal negative 2, we're looking for greater than negative 2. So this, and z is z-score equal negative 2. We're looking for this probability, but table only looking at this probability. So it's the entire probability on the curve, it's 1 minus this one. This one is the probability of z less than negative 2. So probability of z greater than negative 2 is this side. It's the same as the entire curve area, it's 1 minus this area. This area is a probability of z less than negative 2. Z less than negative 2. Negative 2 is negative 2.00. So it's 1 minus, you're looking for the table. Z is less than z, negative 2.00 here. Negative 2.00. That is this value. Negative 2.00 is a 0.0228. So this is a 0.0228 and subtract from 1. So that is 0.9772. Now, question 6. Question 7. Example for your homework, question 7. A contractor decided to build homes that will include, I changed the number, 73.3%, include 73.3% is between this. And if the average size of home built given, average size of home built is 1,500. That's the mean given, the mean. Mean is 1,500. And find the maximum, this side, maximum, and the size of the house, and then this side, minimum size of the house. If the contractor should build. Assume that the standard deviation is 90, so sigma equal 90. That's the question given. So first of all, we have to figure out, here given is 73.3%, transfer to decimal is 0.733. Because we are going to use the z table, we have to figure out those z-score. And those z-score only given you, use the table, we given you the probability is to the left of z-score. So we need to figure out this side how much percent, this side how much percent, because it's symmetry. So under the curve, total probability is 100%, minus 0.733 is 2 sides. So you divide it 2. So each side, this side is 0.1335. This side is also 0.1335, each side, probability. So 0.1335, look at the table, you can get the z-score. Look at the table, 0.1335, 0.13 here, this one, 0.1335, this one. And to the left, you got this, negative 1.1. Go to the top, you got this. So put together, negative 1.11. This probability to the left side is this, 0.1335. Find the corresponding z-score. It's negative 1.1. And then up to the top, 1. So it's a negative 1.11. So this side is negative 1.11. And since it is a symmetry, so the other side is a positive 1.11. And then we convert this z-score to x-score and use z equal x minus mean over sigma. So then x minus mean equals z times sigma is x minus mean. Add the mean both sides. So x equal mean plus z times standard deviation. Z-score is how many standard deviation, actually. So plug in x equal to the mean. Mean is 1,500. Plug in. Add the left side. Z-score is a negative 1.11 times standard deviation 90. And times it and add together, we'll get 1,400.1 square feet. This is the minimum size. The other side is use positive 1.11, plug in. 1500 add 1.11 times 90 and add together is 1599.9 square feet. This is the maximum size of the house, which from minimum 1,400 to up to maximum, this is about 1,600. That covered 73.3% of the house to be built. Then that's question 7. Then next question 8. A survey found that the American family generates an average of 17.6 pounds of glass garbage each year. So here given mean is 17.6. Assume the standard deviation of distribution is 2.4 pounds, so sigma equal 2.4. Those are given condition. And find the probability that the mean of a sample of 40 families, so n equal 40, will between x will between 17 and 18, x greater than 17, less than 18. So we're looking for the probability of x from between 17 and 18. So we have to convert this 17 to z-score, 18 to z-score. Use this z-score formula. Because here n is not equal 1, is 40. So we have divided by square root of n is 40. So first one, the left side is 17. X use 17, plug in minus mean 17.6 over standard deviation 2.4 divided by square root of n. N is 40. So then 17 minus 17.6 is a negative 0.6. Then divided by 2.4, and this divided reciprocal. Square root of 40 go to the numerator. Figure out is negative 1.58. So when x equals 17, corresponding z-score is negative 1.58. So when x equals 18, transfer to z-score. X equals 18 minus mean 17.6 over standard deviation 2.4 divided by square root of n, it's 40, divide. So 18 minus 17.6 is 0.4 divided by 2.4. This reciprocal times our numerator, square root of 40. This figure out, use calculator, is 1.05. So when x equals 18 pounds, corresponding z-score is 1.05. The question wants to figure out between. So figure out this area, between. And since we use table, we only go to the left of z-score. use table. Table give you probability to the left of z-score. So we can figure out this. To the left of negative 1.58 is this area. And also we can figure out by the table to the left of 1.05 we can figure out, and which is all the way, all of it. So then to the left, then minus the 2 minus you will get between. So probability of 7x between 17 and 18 is the same as the probability of z-score between 1.58 to 1.05 is equal to probability of z less than 1.05. On the table give you the total area all the way done. This to the left of 1.05 is this total area. Then you have to minus this area to the left of negative 1.55. So it's minus probability of z less than negative 1.55. So use the table to the left of 1.05. Use the table 1.05 positive side. 1.0 here, this is 1.0. Up to here, 5, it's here. Then intersection, this and this. Intersection is this. 0.8531. So this 0.8531 is to the left. Minus to the left of negative 1.58. Negative 1.58 here. Negative 1.5 here. This one. And 8 here. 8 here. Their intersection is this one. Negative 1.5. And up, it's 8. Intersection, this one. 0.0571. So the 0.0571 is this area. This entire area, 0.8531 minus 0.057. The two subtraction is going to be between this area. 0.796 between it. And the next one, question 9. The average annual precipitation for a large Midwest city, average mean is 29.35 inches. So that means the mean is 29.35 inches given. With standard deviation 3.9 inches, so sigma equals 3.9. Assume the variable is normal distributed. Find the probability that so n equal 1, a randomly selected month will have less than, so looking for x less than 28.8 inches. So looking for probability of x less than 28.8 inches. So first of all, we have to translate 28.8 into z-score. So use this z formula, z equal x minus mean over standard deviation. You can do divided by square root of n. Since n equal 1, so it is divided by 1 is still sigma. So x given is 28.8 minus mean is 29.35 over standard deviation 3.9. Figure out is negative 0.14 by calculator. So when x is 28.8, corresponding z-score is negative 0.14. So you're looking for probability x less than 28.8 is the same as the probability of equal to probability of z less than negative 0.14. So looking for the table, negative 0.14, negative 0.1 here, negative 0.1 here, and 4 here. Together, negative 0.14, negative 0.1 up top, It's 4. It's 4. This is the value. The top is 0.04. Go down. Negative 0.14. Here, this value. 0.4443. No, that's the answer. Next one. Find the probability that the mean of the random sample, the mean of a random selection of 20 months, so n equal 20, will have a mean less than 28.8. So figure out x less than 28.8. So we're looking for probability of x less than 28.8. Then we have to translate 28.8 into z-score. So we will use this formula. 28.8 plug in x minus mean. Mean is 29.35. Mean is 29.35. And the over standard deviation is 3.9 divided by square root of n. Square root of n. N is 20. So then use calculator, you can figure out it's negative 0.63. So when 28.8 translate to z-score is negative 0.63. So looking for probability of x less than 28.8 is equal to probability of z less than negative 0.63. So then use the table. Negative 0.63, looking for negative 0.6, this one. And this is a negative 0.60. This is a negative 0.61. This negative 0.62. So this negative 0.63 on the top is a 3. And you go down, go this, and go left. Negative 0.63 is 0.2643. The next question, question 10. In a survey, 51%, I changed the number. So P equal 51% is 0.51. To move to decimal point to the left, 2 position, get 0.51. Of the voters support a particular fair random. If 50 voters, so n equal 50 given, n equal 50 voters are chosen at random. A, find the mean standard deviation for the number of voters who support the fair random. So mean, this is a normal distribution. Either vote, support, or not support. Support is 51%, not support is 1 minus 51% is 49%, 0.49. So P is 0.51, Q is 0.49. So this is a binomial distribution. We can use a binomial distribution formula, find out the mean and the standard deviation. Mean is n times P for binomial distribution. N is here given 50. P is 0.51, tying together, have 25.5 voters. Standard deviation is variance is equal NPQ. N is 50, P is 0.51, Q is 0.49, tying together is 12.495. Take square root and round it. Since less than 5, you truncate. So it's 3.5348 voters, standard deviation. Then use the normal approximation and the correction for continuity. What is the probability that more than 30 voters support the fair random? So looking for x greater than 30. So we need to do, this is a 30. We're not including 30. So we go to right a little bit, is 30.5 and get continuity. 30.5, use x equals 30.5 and we are looking for this area. So minus mean given, mean from previous part, 25.5. Over standard deviation is square root of 12.495. That's the standard deviation. Divided, use calculator, figure out this is 1.41. That is the z-score, corresponding z-score. So 30.5 corresponding z-score is 1.41. So you're looking for probability of x greater than, more than 30. By continuity, you have to use correction for continuity, use 30.5. The corresponding z-score is 1.41. So find probability of x more than 30.5 is equal probability of z greater than 1.41. And so you're looking for this area. And since on the table only give you this area, so it's the entire area, you minus this area to the left. So it's p minus probability of z less than 1.41. Now you can looking for the table 1.41 positive. So the other side, this is 1.40 and this is 1.41. So is this 0.9207. 0.9207 subtract from 1 get 0.0793. Then next one, the women comprise 78%. So P is 78%, is 0.78 of all elementary school teachers in a random sample of n equal 400 elementary school teachers. What is the probability that less than 3/4 are women? So x should, we're looking for x less than 3/4 times 400, less than 300 are women probability. What is the Q? Q is 1 minus P. 0.78 is 0.22. So we check it. If n times P is n is 400, P is 0.78, get 312 is more than 5 or equal 5. And n times Q, n is 400, Q is 0.22, is 88, is also more than or equal 5. Then we can use the normal approximation. We can use the normal approximation to the binomial. Use the normal distribution to approximate binomial distribution if this condition is satisfied. So first of all, use normal distribution approximation for binomial distribution. First of all, we have to figure out the mean. Mean for binomial distribution is equal NP. So N is 400, P is 0.75, 312. Standard deviation is square root of NPQ. So it's 400 times 0.79, 0.22, take square root. 68.64, take square root. Now x has to be less than 3/4 times 400 is 300. So we are looking for P probability x less than 300. To correct for continuity, we find the probability x less than 299.5. 300 minus 0.5, you got 5.992, 299.5. So transfer 299.5 to z-score. So it's minus, the mean is 312, mean, over standard deviation 68.64. 64. Then you got, use calculator, you got negative 1.51. So less than 299.5 corresponding to z-score is negative 1.51. Then use the table, negative 1.51. Negative table, negative 1.51, negative 1. This is a negative 1.50. Then negative 1.51 here is 0.065. 0.55. Let's get the answer.